All right, guys, so these are our notes from 2.6 day 2 that we took on the board. And what we finished off with in day 1 was the rational exponents and solving when you have rational exponents. We talked about also how to solve when you have a polynomial. So what we're looking at today is solving with radicals. And if you remember, radicals are square roots or cubed roots or whatever, okay? So if you want to solve with radicals, we wrote down the following steps. We said you first have to isolate your radical. So get it on one side and get everything else on the other side. And then if it's a square root, you're going to square it. If it's a cubed root, you're going to cube it. It's a fourth root, you're going to fourth it to the fourth power. So basically, you're going to raise both sides to the n power. So whatever power is in the radical, okay? And a lot of the ones we're doing are just going to be square roots, nothing major, okay? So all of them should be just regular, just square roots, nothing out of control. Okay, so then once you do that, then you're going to solve the remaining equation. So solve. Okay. If there's a radical still, we're going to repeat those steps. And then you're going to check your answer because sometimes they don't always work out. Okay. So those were the steps we went through today in class. So we're going to look at an example. So in our first example, we have the square root of 15 minus 2x equals x. Okay, so this is a square root because there's nothing in the radical. And so if there's nothing in the radical, we assume that it's a 2. So to be able to clear out this radical, first you have to isolate it. Well, it is already isolated. It's already by itself, okay? So to clear it out, we're going to square this side. But if you square one side, you have to square the other side, okay? Whatever you do to one side of the equation, you always have to do the other side. Well, a square root and a square cancel. That's why this allows us to do this. So what we're left with is just what's underneath the radical. And then on this side, we get x squared. Well, when you have an x squared in it, the only way to solve it is to solve it by factoring. So what I'm going to do is I'm going to move everything to one side. And since I moved everything on this side, I get nothing left on that side. And then this side is x squared plus 2x minus 15. So in order to solve this, I'm going to have to factor what's here. So I want two things that multiply to negative 15 but add to 2. So I could do like negative 1 and 15, 3 and 5. That's probably going to be your pair, negative 3 and positive 5. So this becomes x minus 3, x minus 5, and it equals 0. So that zero product property that we talked about in gosh, I don't even remember. I think 2.5 says that you can take your two factors and set them equal to 0. So x minus 3 equals 0, x minus 5 equals 0. So that gives us x equals 3 and x equals 5. But we have to plug those back in and make sure that we are on the right track. So I go back to my original equation, and I'm doing my check now. So my original equation is the square root of 15 minus, I'm going to go ahead and plug the 3 in, so 2 times 3, and it has to equal x, so equals 3. Well, this is the square root of 15 minus 6. 15 minus 6 is 9. Square root of 9 is 3. So 3 equals 3. This one worked out, so that's a solution. So now we're going to plug in the 5. So this gives me the square root of 15 minus 2 times 5 equals 3. Well, this is the square root of 15 minus 10. Oh, I'm sorry, 15 plus 10 because it's a negative 5. What? Oh, this was a plus. I suck. I'm like, what happened here? Gosh, I'm sorry. That should be a negative 5. So then that gives you a positive 10 here. So I get the square root of 25. Well, the square root of 25 is 5. And 5 does not equal 3. So this actually is not a solution since it doesn't work. So your only solution is that x equals 3. Okay, our next example is really long. It's a long example. In fact, it takes up an entire page of our book. So just bear with me as we go through it. Okay, so we have the square root of 2x plus 3 plus the square root of x minus 2, and it equals 4. Okay, so remember when we did adding and subtracting radicals? Oh, I'm sorry. You can only add and subtract radicals that have the same thing underneath. And these do not have the same thing underneath. So the only way you can go ahead and get started on this is to isolate one of the radicals. So I'm going to choose to isolate the first radical. So I'm going to subtract the square root of x minus 2 from both sides. So I get the square root of 2x plus 3. And that equals 4 minus the square root of x minus 2. And I can't combine with the 4 and the x minus 2 because they are both under a radical, and it's like them not being like terms. They cannot combine. So now that I have one radical by itself, I can square this side. And when I square that side, I get 2x plus 3. Okay, that's pretty normal. But when I square this side, this is like having a quantity squared. So you can't just square the 4, square the x minus 2. That doesn't work that way. That's something that we keep doing on our tests. You have to take 4 minus the square root of x minus 2 times 4 minus the square root of x minus 2. Okay? So when I do that, I'm foiling. So I take 4 times 4, which is 16. I take 4 times that, so I just leave that 4 outside. 4 times x minus 2. Then I do it again, so minus 4. I'm going to go ahead and actually write this underneath, kind of weirdly. And then you have the last thing, which is the square root of x minus 2 times itself. And when you take something by itself, or times itself, that's squaring it. So when I square root a square, I'm just left with what's underneath. So I get plus x minus 2. And it's a plus because it's a negative times a negative. So over here I get 16. Since there's 2 of these minus 4 things, that gives us minus 8 square root of x minus 2 plus x minus 2. So I'm going to combine the 16 and the minus 2, so that's 14 plus x minus 8 square roots of x minus 2. So that goes on this side, 14 plus x minus 8 square roots of 2, or 8, x minus 2. Okay, so we can't solve this because we have a radical. So if you go back to our steps said, well, if you get to this point and you still have a radical, then you got to go back and you got to go back to step 1. So step 1 says isolate your radical. So I want this radical by itself. To get it by itself, I subtract my 14 and I subtract my x. So that gives me x minus 11 equals negative 8 square roots of x minus 2. And you could say, well, the radical is not isolated because you have that 8, but that's okay. The 8 can still be there because it's attached to it. They're being multiplied, so they're together. It's like having like conjoined twins or something. They're attached. Okay? So at this point, to clear out the radical, we square both sides. Oh, my Lanta, we're going to have to foil again. I told you this was a long problem. So we're going to change colors. Okay, so to square the x minus 11 squared, that's x minus 11 times x minus 11. That's x squared minus 11x minus 11x plus 121. So that simplifies to x squared minus 22x plus 121. Okay? Then on the other side, we can actually just distribute that in now because they're conjoined twins. They're together, so that's okay. So negative 8 squared is 64. And the square root of x minus 2 squared is just x minus 2. I put a parentheses around it because now you're going to multiply. So I get 64x minus 128. And then on this side, you have all this baloney. And remember, you can't solve an equation with an x squared unless you factor. So what I'm going to have to do is I'm going to have to move all of this to the other side so I can get it to 0. So I subtract 64 from both sides. I add 128 to both sides. Because that zeroes this side out. And then we're going to get some stuff on the other side. So I get x squared minus 86x plus 249 equals 0. I'm going to change colors again. So now I want to factor. So I want two things that multiply to 249, but add to negative 86. And you're just going to have to go through your pairs until you find it. And I already know what the pair is, so I'm going to write them down. So it's minus 3 and minus 83. So at this point, we're probably getting better at this, but once you have two things multiplied that equal 0, you can set the two factors equal to 0 and solve. So x equals 3, x equals 83, and we are finally done. But wait, we're not. You have to actually plug them back in and check them, okay? I am going to skip this step to save some time, but you just plug them both back in. When you plug in the 3, it works out, and the 83 does not. So it ends up that that's not a factor. So it's just x equals 3. All right, so our last thing that we talked about in this section was absolute value equations and how to solve absolute value. So if you recall from Algebra 1 or Algebra 2, absolute value is the distance from 0. So like the absolute value of 5 is 5, and the absolute value of negative 5 is 5, because they're both five spaces away from 0. So what we're going to do is we're going to be given like x plus 2 equals 10, and you're going to have to solve for 10, or for x, I mean. So whatever's in this radical, well, remember that the absolute value of 10 gives me 10, and the absolute value of negative 10 equals 10. So you're going to set this inside equal to the positive and the negative, which is what our rules state, okay? So if you have an equation of ax plus b equals c, where c is greater than 0, and c has to be positive, because if it's negative, an absolute value can never be negative. The distance from 0 can never be negative. So c has to be positive. So if c is positive, and you've got this absolute value equation, then you're going to take the inside, ax plus b, and you're going to set it equal to the positive c, and you're going to set it equal to the negative c. So we did the absolute value of 6x plus 4 equals 8. So to solve this, you take the 6x plus 4, and you set it equal to positive 8, and you take 6x plus 4, and you set it equal to negative 8. So on this side, you subtract 4, you can get 6x equals 4. Divide by 6, and you get 4 over 6, which is 2/3. On this side, you subtract 4 from both sides, and that gives you negative 12. You divide by 6, and you get negative 2. And those are your two answers. Then the other example I did for us was I said if absolute value of 3x plus 4 equals negative 9. This is a no solution, because your absolute value, nothing we put inside these absolute value bars will give us a negative answer, because distance cannot be negative. So if it's equal to a negative, the answer is automatically 0. And then we did one more example, and the example was if I have absolute value of 3x minus 5 minus 4 equals 6. When you do these, you have to isolate your absolute value first and foremost. So you add 4 to both sides. That gives you the absolute value of 3x minus 5 equals 10. Now you set up your two cases. So 3x minus 5 equals 10, and 3x minus 5 equals negative 10. So if you solve this side, you get x equals 5, and if you solve this side, you get x equals negative 5/3. So I let you solve that on your own. So that was 2.6 day 2.